For 33 years, the Linux kernel spoke exactly one language. Then in 2022, that quietly stopped being true. That's the first time it has ever happened, and it's the main line now, and that's Rust. Not the compiler people, you, a normal Rust programmer. Every single thing Rust leans on, gone, and it still works. But by the end of this video, you will have produced that exact line in Linux kernel. Start here. Everything you have ever run lives in that outer band. Need memory or a file, you ask the kernel, and that's called a syscall. But who does the kernel ask? And the answer is nobody, because it's the kernel itself. Up there, what happens? A bug throws and something above catches it. Down here, nothing is above it. So it goes three ways. And the quiet one is the killer. No crash, no logs. So it's real danger. Now think about everything Rust normally hands you for free. That data structure, that syscall, all of them is a favor from the operating system. No operating system, no favor. So they go, look what survives. Here's the bit that surprises people who write Rust daily, and it's very important. Code comes pre-built for real platforms. A kernel isn't one of them. And nobody could pre-build it. Far too specific, endless variations. So a kernel build does something genuinely strange. It builds it. There it is, compiling Rust standard library mid-kernel build, which is why the library's source become a hard requirement. Cargo is the next thing to give up, and this one stinks a bit, genuinely. The kernel's build system calls the compiler itself. There is no package manager in between, because it must build offline and every line gets read. So now let me show you the whole shape before we go further into the discussion. And that's one down. Rust now can compile for this place. Now 4 to go. And the next one is the hardest of all. So let's see. Since running inside the kernel and being useful to the kernel are two different things, everything you would want to call looks like this, a plain C. And Rust can't read a single one of them because it's Rust, it's not C. So we can see there's a wall in the way between Rust and the C. And it's a real one, and nobody is rewriting the other side of it, ever. Which settles the direction. Rust goes to C, never the reverse. So what you can do, you can put a door in it and automate the translation between them. Feed it a C header, get Rust declaration back out. And it cheats beautifully. It borrows Clang to read the C. But if you look closely at what comes out of the other side, it's a raw pointer. There is no lifetime, no ownership, no promises whatsoever. A machine wrote this. It couldn't know what was safe. So somebody has to do that dirty job which a machine simply cannot. They make a dangerous call only once, having actually read the C, and everyone downstream just gets a normal, boring, safe function. Stack all that up and you have the whole architecture with you. Every bit of danger is herded into one small reviewed layer. So by the time it reaches you, nothing risky is left there. It's all safe and secured. There's one more rule, and it's going to explain a flag you'll see constantly. Rust's backend is LLVM. Clang is LLVM. So use one. Two of them disagreeing gives error that make no sense. Now let's get back to the map. That section brought you two more pieces, translated by machine then made safe by hands. Both done. Which leaves the interesting one, the bit that you actually gonna write in the kernel in Rust. Before any of that runs, there are 4 things that have to be installed in your machine, and you have already met 3 of them in the last few minutes. Don't guess that version, the kernel tree will tell you what actual version it needs for your Rust program to run. Then there's one command that tells you whether you got it right or not, and it's enforced, so you have no option. The option literally depends on that check. Fail it and Rust isn't even offered. Pass and it appears. Now flip the switch, start the build and watch the logs go carefully. There will be 4 lines go past that simply did not exist before Rust, and each one is a section of this video actually happening in front of your eyes. That build made 4 things. We have covered only 3 of them. The last one is the only part nobody handed you. So let's open it up. It's shorter than you would think it is. Let's see. First thing to unlearn. This isn't a program you run. It gets loaded into a kernel that's already up and running. So there's no startup. There's a load of this module and then unload of this module. Every single module in the Linux kernel owes the kernel some paperwork before anything else. In C, you type all of that out. Here, one macro does. And that little struct underneath isn't a detail, it's every single thing. Since building that specific struct is what loading actually means, and dropping it is unloading, that's the entire life cycle of the module. 2 events, no init flags, no teardown checklist, just that. And one thing I would like to flag is that notice what init hands back though, a result, not nothing. So if an allocation fails, that question mark bails out and the kernel just refuses it. Nothing left half-wired here. Now carefully look at this one line. 2 things you have never needed. A flag saying this allocation is allowed to sleep first and an answer because down here it can generally say no. Then comes unloading and there's no exit function to write here. In C you'd maintain that teardown by hand forever. Here there's a destructor. You can't forget to call it. So in Rust this is enforced and you don't have to implement it. And that's it. The whole file in 4 parts. There's declare, hold state, load, unload. 32 lines in total and nowhere in it did you write the word unsafe. So it's really easy. Now let's get back to the map and look at what you actually did. 3 of these were actually handed to you. This one you wrote. 1 left. And it's where mistake starts getting expensive. Note that this is very crucial step. So which is why you don't test this on your actual machine. The module we built, don't test it on your actual machine. Rust removed the common bugs, it didn't remove everyone. So you use a throwaway machine that boots in seconds and even if something goes wrong, it costs you nothing. A system that is running needs 3 things and you have already built one. A tool conjures the other 2 from the file system you are actually on. Seconds later you are inside the kernel you just compiled. Your module is still just a file sitting out here. One command and it's through that boundary from the beginning. It's part of the kernel now. Same memory, same privileges that other modules of the kernel enjoys. Look at the logs carefully while you load that module. Your init function ran, so go and read what it said. That's Rust. Printing from ring 0 on your own machine and unload it, the destructor runs and the memories goes back. Now look at it in this way. 10 minutes ago that was out of your reach. Now it isn't. The thing that couldn't read a C header is now answering. And you not even once wrote unsafe to get there. It's really an improvement. So here's the map one last time and it's nearly full. And the last piece just went in, loaded and running. That's everyone. No compiler at the start as it is ring 0 here. So the deal is that you handed over 3 genuine conveniences. And this is what came back in exchange for them. Not the bugs you fixed, but bugs you can no longer write. If you forgot everything else, hold on to this one. Unsafe lives in the wrapper layer. Written once, read carefully. Never in your driver. Get that right and you're fine to go with this. And I want to be clear with you all guys, none of this is a toy. GPU drivers, network drivers, USB drivers in the kernel on your phone. More lands every release, which is where you come in. So whatever modules you're making, make sure it's useful. Now you've got the map. So here's the smallest possible start. Open one of the samples, boot it, change a tiny line, tiny steps on purpose. That's how this actually sticks and you understand everything. 32 lines running in the most privileged code there is. And it got there without one line of unsafe code. That's the whole thing. Now go and write one for yourself. We just wrote the Linux kernel in Rust. There are many more videos that is planned on the topic of Linux kernel in Rust. So like this video, subscribe to the bare